Okay, this is lesson 4.1, algebraic expressions. And this is actually a review lesson. So we're going to review some really important algebraic operations that we're going to use throughout the unit. First things first, an algebraic expression. What is it? Well, it's a mathematical phrase. And it's made up of numbers and letters. We know letters as variables. The first thing we need to review is something called the distributive property. And it's only necessary when there's a number directly in front of a bracket. So for example, we have 2, the number 2, in front of a bracket. And also remember that if there's a sign in front of a bracket, like a negative sign, it's the same as -1. So what's distributive property? Well, that's where you take that number that's in front of a bracket and you multiply it by everything in the bracket. So what do I mean by that? I mean, if we had 2 in front of x plus 1, the 2 would multiply the x and it would multiply the 1. We'd end up with 2 times x, which is 2x, and 2 times 1, which is 2. If we look at b, the number that's in front of our bracket here is not -2x. This is, is not 2x. This says 2x subtract our bracket. The number that's in front of the bracket is -1. So, to open that bracket, the 2x doesn't play into it. The -1 multiplies by the x and multiplies by the -1. -1 times x is -1x, which we can just write as -x. And -1 times -1 is +1. And now if you remember something from the next thing we're going to look at, collecting like terms, we could put our like terms together. But we're going to save that for the next step. In C, the number in front of the bracket is a +1. Well, what happens when you have a +1 in front of a bracket? You would multiply both things by +1. When you multiply something by 1, you don't change it. So this is kind of like a freebie. We just open the brackets and nothing changes. The 3x stays 3x and the -1 stays -1. Because if we multiply them by 1, again, nothing changes. And we have one more here. We have 3y plus 6 times 2y plus 1. The 6 is the number in front of the bracket, so we can distribute that to both terms. 3y doesn't play into it yet. 6 times 2y, 6 times 2 is 12, and 6 times 1 is 6. Now, in all 3 of these last examples, we could continue by collecting like terms. So let's take a look at what collecting like terms is. Collecting like terms is when you have the same variable raised to the same exponent. You can add or subtract the terms that have those conditions. So let's look at 2 examples and see if we can collect like terms. We've got 2b plus 7a plus 8b minus a plus 3b squared. There's a couple terms there that have the same letter. In fact, 2b is the exact same letter as 8b. So we can collect those by using the sign between them. 2b plus 8b is 10b. We also have some a's. We have positive 7a minus 1a. So we can put those together too. 7 minus 1 is 6, and these are our a's. Now, 3b squared is not the same as b, because b squared and b is not the same variable. So, since it doesn't have a like term, we can just write it down. So now, if we go back up here, you might be able to see where we have our like terms. We have 4x and 3x, which we could put together and get 7x. In this example, we had 2x minus x. We could put that together and get just 1x. And in our last one, we got 3y and 12y, which makes 15y. So we can also collect like terms. I'm going to leave one example for you to try. You can pause the video and try it now, or you can go back after the lesson and give it a shot. Make sure you check your answers on the course website. Three, exponents and squaring. What is an exponent? Well, an exponent's a simple way of writing the same letter or number multiplied by itself multiple times. So for example, y, y, y. They're all being multiplied. That's 1, 2, 3 y's, so we end up with y cubed. That's different than if we were to add y's. If we're adding y's, that's 1y plus 1y plus 1y. That would be 3y. So an exponent goes on a variable. So let's try to simplify these and write them another way. If we have a cubed, what that means is it means a times a times a. Another way you might see that written is a. Or you might see it like this, a dot a dot a. All of these mean multiply, and since it's cubed, there's 3 of them. So what would 2 cubed be? Well, 2 cubed would just be 2 times 2 times 2. And we can do that. 2 times 2 is 4, times 2 is 8. What about 2y cubed? Well, that would just be 2y times 2y times 2y. And since we're multiplying, we can multiply in any order, so I'm going to multiply all the 2's first. 2 times 2 times 2 is 8. Y times y times y, well that's 3 y's. That's 3y cubed. Let's try to simplify this. This is going to bring everything together that we just looked at. Distributive property, collecting like terms, and exponents. We're supposed to do exponents first if we're doing BEDMAS, so we've got negative 3x and it's squared. I'm not going to use the 3x. And we've got negative 3x times negative 3x. And then we've got subtract x plus 1. All I did was use the exponent. Now we can do a multiply step. Negative 3 times negative 3 is 9. And x times x is x squared. Our last part, we have a number in front of a bracket. The number is negative 1. We have to use the distributive property. And we get negative x minus 1. And now our last step is to look for like terms. Do we have any like terms? Well, we've got 3x and we've got a minus x. Those are like terms. The x squared doesn't have another x squared in our expression, and the 1 doesn't have any other numbers in the expression, so it's just x's. So I'm going to write my 9x squared down. 3x minus x is 2x. And negative 1 is by itself minus 1. So a little review of exponents and what we can do with exponents, collecting like terms, and distributive property. Now, if you're working out of your lessons package, there's actually a page missing in this lesson. You may wish to go back to the course website at this point and print off the missing page. It would follow this page in the lessons package that I posted on the website. And you might want to pause the video and go print that off. Alternatively, you can write it down on a blank piece of paper. If you move ahead a couple pages in your lessons package, there is actually a blank page at the end of the unit that you could use to finish the lesson. It's right here before the 5.1 lesson, so you could go ahead and do that. I'm just going to take the page and put it on top. So we're actually going to move past number 4. and we're going to go right into number 5. Number 5 talks about factors. And we need to review what is a factor. Well, a factor is a number or expression that divides evenly into another number or expression. So what do I mean by evenly? I mean no decimals. So for example, if you were asked to find all the factors for the number 20, you would think, what numbers divide into 20? Well, 20 can be divided by 1. We would get 20. It could be divided by 2. We'd get 10. 3 would get a decimal, so we can't do 3. 4 works, you would get 5, which means that 5 works, you would get 4. 6 doesn't work, 7 doesn't work, 8 doesn't work, and you can check all these by using a calculator. 8 doesn't work. Let's check. 20 divided by 8. We get 2.5. That's a decimal. That doesn't work. 9 doesn't work, but 10 does. 10 would give us 2. And if we continue all the way up, the last one that works is 20. Those are all the numbers that divide into 20. And the way you can check is start at 1 and work your way all the way up to the number. Now 1 and the number are always going to work. So if the number is 36, 1 and 36 would work, and you'd have to check all the ones in between. The nice thing is, once you get to the middle, like 4, when you divide by 4, you get 5. That's all the numbers. Then you just have to take all the answers you got by dividing by the first few numbers. There's one more set of numbers that works. These are all the positive numbers that work. There's also negative numbers that work. The nice thing is, it's just these numbers with negative signs. It's no new numbers. It's just the negative version of all these numbers. So those are all the factors of 20. I'm going to leave the factors of 75 to you and see if you can come up with them. I'll give you a hint. There's 6 positive and 6 negatives. So you can pause the video and try that now, or you can come back to it at the end of the lesson. We're going to move on to our last topic, integer pairs. Integer pairs are when you're looking for a sum and a product. A product means we're looking to multiply, and a sum means add. So if I was given the integer pair 2 and 3, I would ask you, what's the product and what's the sum? Well, the product means multiply. So we would multiply 2 and 3, and the answer is we'd get 6. For sum, we would add them. 2 plus 3, and we would get 5. One more. Product would be negative 2 times negative 3. Remember, a negative times a negative is a positive, and 2 times 3 is 6. And a sum would be negative 2 plus negative 3. And if you're not sure, you can check in your calculator, but it's negative 5. I'll leave the last one for you. You can give it a shot. We want the product and the sum. Be sure to check online for your answers. The last thing I'm going to ask you to do is I'm going to ask you to take the product and sum and work backwards and find the integer pair. So this could be a little tricky. Product 4 means that the two numbers multiply to 4 and they add to 5. So the way I like to work to find this is I look for the factors of 4. So what are the factors of 4? Well, 4 can be divided by 1. We get 4. It can be divided by 2. We get 2. It can't be divided by 3, but it can be divided by 4. And then all the negatives. So the question is, which pair of numbers multiplies to 4? Well, it could either be 1 times 4, or it could be 2 times 2. Or it could be negative 1 times negative 4, or negative 2 times negative 2. All of these equal 4. But only one of these pairs is going to add to 5. So let's check. 1 plus 4 is 5. Oh, we just found it. Let's check the other ones to make sure they don't work. 2 plus 2 is 4. Negative 1 plus negative 4 is negative 5, and negative 2 plus negative 2 is negative 4. The one that works is 1 and 4. So the integer pair is 1 and 4. Once you find it, you don't have to keep working. Like once you figure out it's 1 plus 4 is 5, none of the other ones are ever going to work. There's only ever going to be one pair. So let's try one more set. We've got negative 16 for a product and negative 6 for a sum. So we need numbers that multiply to negative 16. Well, let's think. We're going to come up with some pairs. I'm going to use my calculator. I'm going to start with negative 16, and I'm going to start dividing it by numbers I think might be factors. Let's start with 1. Negative 16 divided by 1 is negative 16. So a pair that could work would be 1 and negative 16. Let's try another one. Let's divide by 2. 2 and negative 8 is another pair. Let's try 3. 3 gives us a decimal, doesn't work. Let's try 4. 4 gives us 4. Sorry, negative 4. And as soon as the numbers match like this, we're almost done. The only other pairs that could possibly work now are with the opposite signs. So we could have negative 1 and positive 16, negative 2 and positive 8, negative 4 and positive 4. And those are all the pairs. Now one of these pairs is going to add to negative 6. So now we just have to go check. 1 minus 16, that one doesn't work. 2 minus 8, hey, that's negative 6. That's our answer. 2 and negative 8. So none of the other ones will work. I'm going to challenge you to find the last integer pair. Look for two numbers that multiply to negative 27 and add to 6. And that's it for lesson 4.1. Thanks for watching, and I'll see you in lesson 4.2.